Hello everybody on this fine day and welcome to my presentation for Robotics 211 at University of Advancing Technology. Today I am going to demonstrate a traffic light system, a northwest style traffic light system, using nothing more than Boolean logic, a microcontroller, and a little bit of ingenuity. So let's begin. Okay, here's my code, my great code, and I love it. So we'll just get into the nuts and bolts of it. As usual, I include two header files, the AVR header file and the utility delay header file. I defined the CPU here at 16 megahertz. I have a huge delay time of 100,000 milliseconds. So yeah, the reason why I need that is because I'm actually kind of cheating. I'm using the Adrenal board hooked up with this microcontroller, and the Adrenal board has a crystal sync clock on it, which runs twice as fast. So it's running fast, but I needed it to slow it down to somewhat look like how a traffic light would work, and that's the best I could do. It works. It works good actually. So I have a couple of defines in here. Obviously, delay time is one of those. LED port, LED pin, LED DDR. Port is basically the call that we use to switch something on or off, 1 or 0. Pin is going to act as a read, um, for a pin if it's an out if it's an output. DDR it's going to basically tell your register of pins if they're going to be inputs or outputs. You define them. Anyway, so wait a second here. I have some code in here that shouldn't be in here. We have a straggler, guys. We need to get rid of that. That's doesn't affect the program, but that is a piece of memory that we don't need in there. So I'm glad I caught that. Okay, so anyway, what we do is we set the DDR, the data direction, and port for D using binary. We set all of those to outputs. Now I could use 0xFF, and that would be the binary version of that, but I decided to do it longhand just to be a little bit more clear. And the rest is simple. So what I do, I keep it simple, okay, but it works very good. We start off by writing to the LED port, which is going to be port D, which ones are going to start off and on. So if you look here, we start off, I have two sets of light, red, yellow, green, and blue, okay? We all know what red, yellow, and green mean with the traffic light, but the blue is something special. The blue is basically your crosswalk. And when the blue lights up, it's supposed to mean that the pedestrians can cross. And when it turns off, it means the pedestrians can no longer cross. So I decided to take it that far with this. Okay, so now that we know that, this is how it works. We have registers 0 through 7. Okay, 0 being on the far right, 7 being on the left before B, which the 0B stands for binary. So how I have it is red, yellow, green, blue, red, yellow, green, blue. So the very first lights that light up are red and blue on the north side, and then green on the west side. Okay, and then we delay a certain amount of time, and then if you look at the code, red and blue are still the same, but we take the green and swap it for a yellow light. Now I could have used a bit mask for this. I do know how to use bit masking for this, but I decided to keep it like this because it's a lot easier to read for a newbie like myself, basically just to see what's going on. So I can see here that light or that pin turns off, and then this pin here that's off turns on. Okay, so green turns to yellow. Then we wait, and then on the other side, green lights up, and the red and the blue go away. and then we have the blue and the red on the western side, or on the other side, light up. So here's how it works. You have a red light on one traffic light, a green on the other. When the red light is on the traffic light, the pedestrian light lights up so you can walk. Okay. Then the green light is going to turn to yellow because we need to signal the drivers that they're going to have to get ready to stop. And then that'll turn to red, and then the pedestrian light will turn on that side, and then the green light will turn on the opposite side. Okay, and then the green light will turn to yellow, and then it repeats and it repeats indefinitely. And that's exactly how a traffic light system works. You have red and green, and then green turns to yellow, and then yellow turns to red, and then that red on the opposite side is going to turn to green, and it's going to go vice versa. I tested it out and it works great. So let's test it out. Actually, let me clean this up a little bit. The one thing I do not like is dirty code. Oh, uh-oh. Let's go back. Okay, that's good enough right there. Okay, so build it. I'm going to show you that it builds just fine. Let's do it again. Oh, there it is. So as you can see, the build succeeded, and it works. So without further ado, I will show you an example of how it works. Thanks, guys. Have a great day. Hey, everybody. Okay, so here's my assignment for the traffic light. As you can see, you got a red light. The blue indicates a pedestrian walk type thing, and then you have green, yellow. You know, red, green, and yellow for the traffic lights. It's got two sets. They're side by side, but it's supposed to represent north and west. So right now we have one traffic light, red, with the pedestrian on, and a green light. That green light just turned to yellow because it's getting ready to turn to red. And then when it turns to red, the pedestrian light goes on so the people can walk, and the green light goes on the other one. Now it's turning to yellow. It's functioning just like a traffic light should function. And it switches over. Now you got one side green, the other side red. And that side that has the red light has the blue light, which indicates pedestrians walking. As you can see, the other light went from green to yellow and now to red. And then the crosswalk is basically activated on the other side. And the green light is on the opposite side. Now it turns to yellow. And then it's going to turn to red. And on the opposite side, you have the green that goes on. And it just basically functions like a traffic light. That's exactly how a traffic light functions. So one side you have red, the other side you have green. Green is going to turn to yellow, indicating that you're going to slow down. There's going to be a change. And then it turns to red to stop. And then the opposite side turns green. And it repeats. Pretty cool. Using Boolean logic. Pretty cool. Okay, guys. Anyway, that's enough of a demonstration, huh?